In this video, I'll just go through a couple of, I think they're VCAR questions, but a couple of general maths exam questions here. So I'm going to do 19, 20, 23 and 24. Let's see how they go. So 19 is the second part to this question where we've got a loan and the loan is monthly, or it's activated monthly, I suppose, by this recurrence relation. Okay, so to answer 19, we're going to look at how long the loan takes to be repaid. And what we need to do, we need to get all of the information for a financial solver out of the recurrence relation. So we can see that the initial value of the loan is there. That's easy. The payment is there. We just need to get the interest rate out of this. Now remember that 1.003 value was calculated by doing 1 plus the rate, whatever it is, over 100 times 12. Okay, and whatever that rate is, that will give it to us. So we can actually just do a solve on this. So we're going to go solve 1.003 equals 1 plus x over 100 times 12 for x, and it tells us that the rate is 3.6. Okay, so r equals 3.6%. Alright, so we've got all the information I think we need now, so we'll go menu 8.1. Now, n is what we're trying to find out. The annual rate is 3.6. The bank gave whoever it is the money. The payments, they gave the payments to the bank. The future value is 0, 12 and 12. So it's n is 300, alright? So that's the number of payments with a small change to the last payment. So that might be marginally more than the standard 2024, but that's okay. Alright, so all we're going to do then is we're going to go 300 payments divided by 12, means the loan is going to be paid out in 25 years. So a bit of a tricky one, that one. Okay, this one here, Needy owns equipment that's been used for 10 hours per day for 365 days of the year. The value of the equipment is depreciated by Needy using the unit cost method. So that is deduction per use. The value of the equipment after n years can be multiplied by the recurrence relation. Here it is. Alright, so the recurrence relation, what it does basically is it removes this amount from the previous value every year. So this is the annual depreciation rate. So I'm just going to write that down. Annual dep is 5475. And then looking at how it's depreciating, we've got 5 options, either a per hour or a per day depreciation. So I'm going to work out, or try to work out, the per hour depreciation and then just see how I go from there. So I'm going to go and say that the hours used per year, so we're doing, so per year hours is 365 days a year of 10 hours per day. So 365 days, 10 hours a day means it's used for 3,650 hours. To get the hourly rate then, all I do is I split the 5,475, the annual depreciation, by 3,650. So just divide them. 5475 over 3650. And that one there is $1.50. So $1.50 per hour. There it is right there. Okay, on to the next question. Okay, so that is this one here. Lee invests $4,000 for 5 years, 3.88% per annum compounding annually. Alright. Joseph invests a sum of money for 5 years which earns simple interest, so the same amount each time, paid annually. Let let JN be the value in dollars after n years. The two investments will finish at the same value if Joseph's is modelled by this. Okay, so what we've got to do is just work out the value of Lee's investment after 5 years, and then just see which of these ones here matches Lee's. Alright, so we're just going to jump back on Financial Solver. We're going to do 5 years at 3.88% per annum. Gave the bank $4,000. Nothing mentioned about payments. And it happens once a year. So now what we're going to do is work out the future value. So Lee's investment would be $4,838.60. Alright, so all we're going to do now is just try each of them, and I can't think of a better way of doing this one. So try each of these to see which one matches 4,838. So the first one, option A, is $2,000 invested plus 5 lots of this annual interest that's being paid out. So 467.72. And that's it, is it? No. No, way too low. Alright, so let's just change that to 2,500. 367. It's the same amount. Alright, so no, let's do 3,000 plus 5 times 317.72. A little bit more this time. Okay, I reckon it's the next one. 3,500 plus 5 times 267.72. Bingo. Alright, so this one here means that Joseph, after 5 years, will match Lee's compound investment. Alright, this one. Yeah, I've recognised this one. This is from a VCAR exam. So, yeah, this was hard, this one, I thought. On the 1st of January 2020, Dion invested this, paying this interest quarterly. Okay, so that's important to know, that that's the quarterly interest. Okay, at the end of each quarter, after the interest was credited, Dion added an additional amount of money. And DN represent the additional amount in dollars added at the end of quarter N. So DN plus 1 is the same as DN. So this recurrence relation basically says, it's basically saying same amount added each time. Alright, so I think all we're going to have to do is work out what the amount being added is, and that will be the value of C. Alright, so the balance after 2 years was this amount here. Alright, so let's just jump onto Financial Solver. And we're doing this 8 times, so 2 years of 4 times a year, that's quarterly. Now the quarterly rate is 0.52 times 4, because we want to get that into an annual, okay? Alright, now he invested, so he gave the bank 10,500, and the payments, that's what we're after. Now at the end of that, the balance, or in theory, the bank would give Dion this amount of money, where this is happening 4 times a year. 4 key doesn't work on my computer. 4. Okay, so this should be the payment. Yep, there it is. Alright, and I don't know, like the question's a bit sketchy because what it does is kind of hides behind this recurrence relation. You need to understand that what the recurrence relation is saying, or the additional amount, is modelled by this recurrence relation. So it's saying that the next amount being added in the quarter is the same as the previous amount. So the amount added in the first quarter will just be the same amount that's added each time. So this is the amount that's going to be added. So yeah, I thought that this one hid behind a little bit of notation rather than a really complex kind of question. All right, so there you go.